Hey guys, I just wanted to record something real quick for today's assignment because I figured some people would have some questions or were confused about yesterday's thing. So that being said, I'm going to run through this in kind of a simplified way. I don't want to give you all the answers, but I do want to get you in the right direction because I realize this might be kind of confusing, especially since we're not in the classroom. If you're still having issues with it, I will be on Zoom at our scheduled times today at 10:30 and at 1:30. I know I've already had a couple people that um, have asked questions and have asked to join that, so we'll talk about this during the Zoom meeting. I don't want you guys to get too far behind if you were not quite finished with yesterday's thing, but I'll try and help you through it, and I'll be understanding on time restraints and anything like that. So if you still need to finish this over the weekend or anything, that's fine with me. But either way, I want to get into this real quick and just talk about how this is going to work. I tried to make this as simple as possible for our purposes. So yesterday you were given sample data with elephant counts, just that I made up. The numbers didn't necessarily relate to any actual data. But this time you're going to be taking the sample data, obviously not with any organisms because I'm not expecting you to go out and count individual organisms. That'd be very tedious regardless of what you pick. Instead, I made this little picture with macaroni pieces, and you're going to try and estimate how many macaroni pieces there are on the page. You can count if you want. It's a little tedious, and I'll know if you counted because you'll come up with a different answer than if you estimate. I counted 84, and I tell you that on one of the questions. You might get a bigger or smaller number if you count these small pieces. I didn't really count the small pieces that broke off there, but I don't know, it's up to you. Either way, there's 84 pieces there total, but if you didn't know that information and if you were trying to estimate how many pieces of macaroni there were, let's say in the box or whatever, I won't ask you for that calculation today, but just in general. Here's how you would do that. So it's the same principle as what you saw in the video on Tuesday and the same thing as what you did yesterday. So what you're going to do is you're going to, instead of counting every individual piece, which you could do, it would be faster to count pieces in these transects. So you have three transects that I've drawn on this piece of paper: transect A, transect B, transect C. They're all the same size. I made them 1 inch wide, as you can see here, and 8.5 inches across, which is the width of the paper. So they should all have the same area. All you have to do is multiply length times width, and since the width is 1 inch, the area should be fairly easy to get. It's just the length times 1, which will be whatever it is, or the length. So what you can do with that information, knowing that each of these areas is going to be the same, 8.5 inches squared. With that information, you are going to find the total population of macaroni population inside each transect, and then divide that population by the area to get the density. So this is the only thing, or not the only thing, but this is one of the things that I think will confuse a lot of people. When you are counting organisms, or in this case macaroni, in a transect, obviously since you have a very defined grid, and organisms are not always going to put themselves into that grid nice and neatly, you will count any organism that is on the line. So anything that's close, count it. And it's going to kind of come up to judgment on a couple of these. I'm going to be lenient. You don't have to get exactly the same number that I got when I calculated this. I'll at least be able to tell if you're close. For example, this one very, very clearly is in for the most part. There's a little bit hanging out, but we'll count that one. But this one, for example, some people might count that, some people might not. It's just barely touching the line. I believe I counted it when I did my counts, but we'll see. So anyway, if it's on the line, if it's close, count it in that transect. The only way it won't be in that transect if it's completely out of that box, like this one right here. So this one obviously is not in that box, so we're gonna not count that one. So, for example, 1, ooh, that's an ugly circle. Let's just do dots. 1, homework. 2, if you count that one, you might not count that one. 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of macaroni in that first transect, give or take. Again, you might not get the exact same count depending on your level of scrutiny, but I got 11. So what we're going to do with that information is we're going to find our density. We have 11 pieces of macaroni over an area of 8.5 inches squared, which gives us on average about 1.3 pieces of macaroni every cubic inch. So that'll be our area, or that'll be our density for the first transect, and you're going to do the same thing for transect B and transect C to get your average. So add the density of transect A to transect B, add both of those to transect C, divide those by 3 to get your average density, and then what you're going to do with that average density is you're going to multiply the average density by the area of the paper. So the paper is 8.5 inches wide times 11 inches long. That's the average size for a piece of paper. So the area of the paper is going to be 93.5 inches squared total. So whatever you get for your average density, multiply by 93.5, and that will give you some number that will estimate the number of pieces of macaroni on the paper. And again, when I counted, I got about 84 pieces, give or take, depending on, again, your level of scrutiny or if I messed up my count. But either way, that's where you're going to be comparing your number to. So 84-ish is the actual number. What is your estimate? And you're going to compare, is this a reliable estimate? Is it close? And again, it's kind of come up to you. Like if you think it's close enough, some people think it's not close enough. What are ways that we could make it more specific or like closer to our actual number if it's off by quite a bit? Things like that. So I think I covered this in a way that introduces it without giving away too much. If you're still confused, either email me, or if you're really confused, like I said, I'll be on Zoom at 10:30 or 1:30. And if it requires more than that, I've got nothing else going on anyway, so it doesn't have to be restrained to those 30-minute intervals. So let me know. But either way, let me know if you have questions. Hopefully this isn't too bad. I'm trying to make it as simple as possible. Again, I know I'm going to say this a lot throughout this, but it would be a lot better if we were actually in the classroom because I could walk around and help people and it'd be easier to get. But communication is limited during these times. So do your best. I'm going to be lenient. Not to say that you should completely bomb it, but at least try. And as long as your numbers are relatively close, I'll give you the points for it. But we'll see. It might be a struggle. But either way, let me know if you have questions. Get on the Zoom at either 10:30 or 1:30. If you have any questions that you need to discuss in person, or if you just want to hang out. But if you do want to hang out, make sure you're leaving time for the people that want to ask questions. And then have a good weekend, guys, and I will see you next week.